Good morning, afternoon, or evening, depending on where you are in the world. Thank you so much for attending my talk. Today we're going to get into container image vulnerabilities and how developers and developer teams can deal with them. My name's Eric Smalling. I'm a senior developer advocate at Sneak, but I'm not really here to talk about Sneak or any of our products or anything like that. Today I'm here to talk about our experiences, what we've seen out there, and how development teams work with their containers and deal with their vulnerabilities that are found in them. A little bit about myself so you know where I'm coming from. I have a development background, been doing it for about 30 years, depending on how you look at it. The last decade or so has really been around consulting in the DevOps space, CI/CD. Discovered Docker in that time frame way back in the early days, 2013, back in version 0.6. And actually ended up working for Docker for about 2.5 years as a professional services consultant with enterprise customers. Also worked for VMware consulting there. I've done Kubernetes consulting. I've got some certifications and all that, whatever about me. There's my info if you want to look me up on Twitter or LinkedIn, feel free. That's enough about me. Let's talk about what today's key topics are. Two main areas. First of all, from an individual developer point of view, how do I deal with base images and vulnerabilities and all the things that I have to fight as far as security and, building containerized applications. Secondly, how do I apply those practices that I come up with there across a team of multiple development teams across an organization and scale it? And as we go, we'll be talking about some of the practices that myself and other of my colleagues have seen at client sites, as far as what's good, what works, what might not work everywhere, that kind of stuff. So there are three key principles I want to open up with here. Whatever process, and we're just going to talk about process today. We're not going to get into tooling, because there are many tools. Of course, I obviously have a favorite, but whatever tool you end up using, you want to make sure your practice is repeatable. No matter what kind of container, what kind of application team is using it, the security practices you come up with need to be able to be used by Java developers over here, Python developers over there, Node.js, whatever. You don't want to have separate security processes for each team. Secondly, efficiency is one of the reasons why we love Docker and containers in general, because containers allow you to deploy quickly. They give you a standardized set of artifacts to deploy everywhere. The orchestrators allow us to run things more easily and sustainably. So we don't want to come up with a practice that invades on that efficiency, right? So we don't want to make it so that it's whatever governance or anything we put in place is so onerous that a developer throws up their hands and says, I'm just going to go do whatever I want and start up a shadow ops cluster somewhere else, right? That's not going to be helpful. And finally, as a developer, I really am not that interested in becoming a Linux sysadmin. The sysadmins are crucially important, and so as are the security teams. But that's not what I do. I code, I create, I troubleshoot. I'm not really interested in switching jobs and becoming an expert in package management or file system permissions and all that. I also don't want to sit there and, while I'm drinking my coffee in the morning, reading CVE reports and tracking what's the latest vulnerabilities that have been fixed in a given middleware package. It's just not what I do. So we don't want to come up with a practice that tries to turn our developers into sysops or security AppSec experts. So let's get right into the developer day-to-day. So we want to have a system for cleaning up container vulnerabilities. That's the whole point of this, right? And from a developer point of view, the first and probably the most important aspect is your code and your code dependencies. This is the area that you have the most control over as a developer. You wrote the code, you picked the dependencies to come in, or you as the team did. You should have practices in place to make sure whether they be scanning tools or code review or whatever, to make sure you're not creating vulnerable applications yourself. We're not really going to talk about this in today's session because that's, you have total control there. There's not a lot I can add to that with regard to containers. However, the base image, the thing that your container is starting from, the base, is the majority of what we're going to talk about today, because that's probably not only the most impactful area, the area you can have most impact on, But it's also probably the hardest area to deal with because the base image isn't yours. You got it, you inherited it from somebody, whether it be an official image from a registry provider like Docker Hub or Red Hat or somebody, or you got it from another team in your company, but you're taking it on and now you have to deal with it, right? Then there's the layers you add to your image yourself, the packages you add, whatever you're doing in your Docker file. These are important and we'll touch on it, but this isn't really the core area because again, you're in control of this. You know what you're adding to your image, and if you're electing to take control of that, that's your choice. Finally, there's also the configuration, mainly the runtime configurations we're talking about here. We're not going to get into that because that's, I mean, there are entire conferences, thus, KubeCon, that talk about this kind of a thing. So in that case, in this case, we're talking about things like, running your container without a root user, running with a read-only file system, using network policies in Kubernetes, all of those kinds of things. Those are crucially important, but we want to focus today in the limited time we have on the container image itself and making sure that it's solid so that when you get to configuration and runtime, that we at least have a safe application to run there. So fixing containers when it comes to security is not like the old school when we're working in VMs. We're not that as interested in where the problem is and the library that's the issue and patching around it and the minutia of that. What we're more interested in is how the vulnerability got there. Where did it come from? Did I add something that caused us to have more vulnerabilities, or did I inherit it from the base image? That shift from figuring out what's the problem to how did it get there kind of changes how we think about a fix for this, right? So that base image, picking one of those, it's not really as simple as it seems. If you go out to any of the major registries, Quay or Docker Hub or whatever, you will see lots of generic images. For instance, from Docker Hub official images, we have a Ruby image. There's also things like OpenJDK, there's Python, MySQL, MongoDB, all these general images. They're meant to kind of satisfy the general needs of a lot of developers. These images are pretty big. In fact, the Ruby one, when we created this slide, we were seeing almost a gig of stuff in there. And the more things you have in an image, the more vectors of attack a bad actor could have, the more spots vulnerabilities could hide. In the case of Ruby, we're seeing there were 35 high severity vulnerabilities at the time we looked at it. I think it was back in the spring when I made this slide. Now, on the other side of the spectrum, we have the slim tagged images. Slim images are basically where the community has come in and they've created an image that is very small. They've stripped out a lot of extra stuff so that just, it's a loaded word, but the essentials, if you will, just the essential things are there for running, in this case, a Ruby app or a Python app. The nice thing here is that by stripping out all that extraneous stuff, you vastly reduce the number of vulnerabilities because they're just not there to, the exploitable things aren't there anymore. The downside, though, is that there's a lot of things that in the general one you might need, especially to build your app. So you now are having to add back in the individual items you need. Now that it's nice because you have a list of those things, but you're starting to move into that sysadmin role again. Now you're having to keep track of what packages do I need in my image to build my app. Now, in between Slim and General, there are a lot of other image tags and different versions of images and flavors. For instance, Ruby has over 700 listed in Docker Hub just for the official Ruby images, not including all the open source ones and other teams that have created Ruby images. So how in the world would you know which one's best? Well, some advice here. So best practices. I generally would say that the generic Ruby, the top level one, is not what you want. It's great for experimentation. But the problem is, especially if you just say from Ruby, well, now you're just getting whatever version's the latest thing. And while being on the latest is a good practice and you want to be on the latest, you won't know if you don't use a tag. So you need at least use a specific version tag so you know what you're getting and you can have a reproducible build. Because today, you build it today, and then you build it tomorrow, you don't know that they're going to be the same thing. There's also a lot of other things in those Ruby packages. So even if you are sticking to a version tag, they could be upgrading other packages behind. The tagging is not a immutable thing in container land, unfortunately. You can reuse tags, you can move tags. Generally, again, for experimentation, the general images are good, but not for anything you're going to check in and cause a image that'll get deployed to your servers. Slim isn't automatically the best choice either, because all the vulnerabilities, they may reduce the number of vulnerabilities. There might not be all the ones that are in the general one, but now you get to manage all the build dependencies so that you have to take on that role in keeping track of what you're adding. So let's take a look at a couple examples of Docker files, both with the general and a Slim version first. Here on the left, we have a Ruby 2.7.0 base image. Now you'll see I am not just using Ruby latest. I'm using an actual pinned version. I personally think that's important because you want to know what you're building against. You don't want to just take random whatever Ruby is at right now. So we have our normal stuff where we need a database. We actually just need a database library, but we're going to install SQLite, and then we'll do our build, and we've got our Rails app ready to run at the end. Again, problem with this is that we have a lot more than we need at runtime for this application. On the right, we're using a Slim version. We actually are tagging to the Slim Buster, which is a version of the Debian distribution. Since we're using Slim, though, there's a lot of stuff we need to build our app that isn't in there anymore. And we've had to go through and find all the packages that we need in order to successfully build our app. Now, I don't know that we actually need Vim in our build image, but so ignore that line. But other things, we needed all this in order to build the application. And when we're all done, we have a smaller image, but I'm having to manage now all of these packages. I need to know, that I need to include Ruby Dev, and what version of Ruby Dev do I have? Technically, I probably should have an @ sign and a version number here because I should be pulling in specific versions of those, and I should be managing that. So it's just another set of things you've got to take care of now, and be an expert on all the versions of libLZMA and all that stuff. So it would be nice if there was a happy medium between the simple Docker file you can use for with the general, or the smaller image that you get with Slim without having to do all this extra work of managing packages. And this is where Docker multi-stage builds come in handy. So now on the left, you're seeing a multi-stage build. And if you're not familiar with these, this is a feature Docker added back in, I think it was 2017, that allows you to have multiple from lines in your Docker file, and each block they call a stage. So from one from to the next from is a stage. And here you can see we have the generic general Ruby 2.7.0, and we're tagging it with this as keyword, and we're calling it build env. There's no difference here for the build. We get to here and we have the Rails build done, but then we have another from line. This file has two stages. The second stage, or the final stage in any Docker file, is the one that actually produces the image that you end up pushing to your registry and pushing to your servers. In this case, we are basing on the Slim image, and we've got a few variables for setting up and whatnot, but all we're including is the database driver we need. And then finally, we run the app. So the image that goes out doesn't have all the extra stuff that the Ruby general image tag would bring in. It just has the Slim plus this library and of course our app. And the way our app comes in is down here in lines 39 and 40. You see the -- from tag. That's saying from build env, which we defined here at the top. Bring in, and we've declared these variables up top, but bring in all of my Rails and Gems code, compiled code into this final stage. So the image that go out has the best of both worlds. It's smaller, but I also am not having to manage a bunch of libraries and packages separately. So as you can see, multi-stage is pretty cool. I am a big fan of multi-stage. I suggest you learn it, you love it, and if you're using Docker files to build your images, multi-stage is the way to go. Some general recommendations here about making your life easier. So you are going to, even, we talked about not becoming a sysadmin. Well, you are going to need to know a little bit of sysadmin. A little bit of knowledge is unavoidable. You're going to want to pick a distribution that you're based on. So if you're doing multiple different kinds of images, you're going to want to stick to the same base. So if you're you're using Debian-based images over here, you want to use Debian-based images around, because that uniformity will aid in your developer team being able to move around between products, projects, applications, and not have to relearn a new file system or a new idiosyncrasies of CentOS versus Ubuntu or RPM versus apt, right? Secondly, pin to versioned images. As you saw in my little demonstration there, I was using a specific version of Ruby. I specify all the way down to the build number, the third digit, or depending what kind of versioning scheme that they're using. You could just do the major, at least do the major, but remember that's going to be a rolling tag. It's going to move. Major minor is better. Major minor build, I think, is the best. The hard part there is that you need to keep track of what's the latest. You're not going to always get the latest if you're pinned to a specific build. So weigh that with your processes, your existing processes, and see what works. Now, let's talk about back to getting rid of vulnerabilities. As I said earlier, learn to love multi-stage builds, unless you're not using Docker files for some reason. Secondly, let's talk a little more about Slim. I don't have it on the slide, but Slim's good, but there are other package types or distributions that might be interesting to you. There's one from the Google open source team called Distroless, which is ironic because there is a distro, but whatever. Their version of some of these images will have nothing but what is needed to run OpenJDK or Python or whatever. There's no shell in there. There's no package manager. It is really, really minimal. This may be perfect for you if that minimal image works for your application. Where that might not work for your teams is if you have to make modifications. For instance, the Ruby example where I had to add a database library. That's fairly simple. As long as I know where I'm getting that library for, I could copy it in. But since there's no package managers, you can't just add things easily. You're going to have to source the things you're bringing in and build them or house them somewhere and bring them in. Going to need to know more about the operating system than the average, the person who just runs, yum install. There's additionally, the lack of a shell shouldn't be a problem because you shouldn't be execing into your containers anyways, but you need to be aware of that. If you do that to troubleshoot, you're not going to be able to do it on those, which I would say is a good thing, honestly. But and there's also Alpine. So Alpine is a Linux distribution that's almost a different operating system. I mean, it's still Linux, but it's compiled on Muscle C instead of glibc. They predate Docker even. They make Alpine is a distribution that focuses on very small footprint operating system. It's BusyBox based. Check your licensing concerns if you have any issues with the BusyBox, and I think it's GPL, maybe. Don't quote me on that. But the challenge with Alpine is it's great, it's tiny, it's terse, there's not a lot of things in there to exploit. However, because of that Muscle C versus glibc, you could have technical problems with it. For instance, if you've got a legacy app you're bringing in that it's a Java app, say, and it has JNI calls out to some SO file. Probably not going to work unless you're rebuilding that SO for Alpine. Same with anything that compiles to binary. You want to make sure it's compiled to Alpine or else it won't run. Generally. Rebuild often. So, I'm sorry, I skipped one. Let Docker, Red Hat, Bitnami, whoever it is you're getting your base images for, let them be your sysadmins for the bulk of things. Those teams are putting in all this effort to produce the safest image they can produce for you. If there are vulnerabilities in a official image, generally there are no fixes for those vulnerabilities in the open source community. So they've already done the work to make sure that you're on the latest versions of things to minimize the number of vulnerabilities. So don't reinvent a wheel that they're already inventing for you. Trust them. If you're already using them, trust them and continue and do that. Don't try to start from scratch and build your own distros. It's just you're asking for it if you do that. Rebuild often. So you want, as I was saying before, when you're on a version of something, you don't want to get stuck there forever. You want to move forward with versions as they come out. If you're using just a major minor, you are going to get that if you just rebuild. You're sacrificing some knowledge of what you built because you don't know what the build number, the third digit would be. But if you're using the third tag, that this is like the pins comment. You're pinning to a version. move that pin, because you don't want to end up getting stuck on a version so long that it becomes unsupported. And you want to take advantage of the fixes that are coming in the new versions. One other topic we really want to touch on is a lot of people will strive to get to 0 vulnerabilities. Admirable goal. However, it's almost never possible on the larger packages, right? So, as I said, the base images, the official images, often any vulnerability found in them there is no fix for them. So you're going to be, in order to get to 0, you're going to be carving those images up to remove things on your own, and now you've got to manage that. So you're almost forking the image, if you will, into your own version of it. So admirable, and you may need to fix some of the, there may be things in there that you just absolutely cannot deploy the way they are, and okay, we'll talk about that a little bit in a minute. But just don't kill yourself trying to get to 0. Deal with the ones that are most impactful to you. So those processes are great on a micro point of view. But let's talk about the macro now. Let's talk about when you have multiple development teams. How do you scale this across them all? And if you look at the image structure, it's layers, right? And if you can start to think about organizationally structuring around that as well. And at the lowest layer, you have the base images that you've gotten from whatever external source, whether it be a registry or actually a company giving to you. And you then have sysadmins, security folks. This is where they really come in and can help you harden and put your company custom configurations on that and create a base image for your organization. So in this case, we call it myorg/base. This could be myorg/Debian or CentOS or whatever. So it's got base image plus my company's special sauce, right? Then common software teams can come on and add in things like languages, frameworks, middleware. So you could have the team come in, put it in the OpenJDK and Tomcat, and you produce myorg/Tomcat or Java or Python or Django or whatever. And then finally, what we've been talking about already, then your application developers don't have to worry about all that stuff. They just worry about their applications and how they are laying on top of those base images. Now, the promise of this is that we are trying to get to where we can scale vulnerability management so that the panacea would be, I fix it once and everybody gets the fix. So these base images that come in, if it's at the OS level, we find a vulnerability, we move to a new version, we do whatever we need to do to fix that, and then everybody downstream then can rebuild on top of that and just gets the goodness of that fix. Middleware teams could be in the middle of that. They could do the same things. Like new version of Tomcat comes out, they upgrade that, and then all the Java Tomcat developers would rebuild on top of the new image. This is great, but you need to make sure that you have some kind of signaling mechanism that lets the downstream consumers of those images know there's a new version, or else they're going to sit blindly on the older version and not get these fixes. So let's talk about teams and responsibility. So given the example I was talking about, the strata, the layers of the image, we see at companies usually 3 different ways this gets done. First is the kind of the full stack team. Like, this team does everything. They do their app, they worry about the common frameworks and middleware, the languages, and the operating system level. They own the whole enchilada. And every team does that, and hopefully they communicate with each other so they're not siloing and reinventing wheels. But that's the easiest one to look at as far as how to do it. Or the flip side of that is you have a centralized team that does all the images for the company, and they own the whole enchilada, but they own it from the point of view of app team gives me their code base, we make image from it, kind of a thing. Get to the pros and cons on that in a minute. Second way that we see things done is you have a base image team. This team is made up of engineers and security and sysadmins and storage and whoever. They produce the base images for all the application teams to use. So my company / Tomcat comes from this team. And then the third example is kind of an extension of that, where you break that up into the team that produces the lowest level base image and certifies that the images we're getting from external sources are up to snuff, and they vendor gives them image, they test it and certify it, say, yes, this is blessed, we can go ahead and use it. And then a hardening team comes on top and does all the company specific stuff. And then the app common software team comes on top and does that. And then the developer teams, you have a hierarchy going on there. So the pros and cons of each of these are probably kind of obvious, but the first one is that it's simple to understand who's responsible because the team creating the image owns it all. Whether that be individual teams across the organization each own their full ownership of their images, or it be that centralized container team. The cons can be this can produce chaos. If they start to silo and you've got all these teams doing their own things, you could have one team that's doing images a certain way and another team that's using totally different tech and totally different process. And if you have a vulnerability crop up in a common piece, if they're not talking to each other, not using the same process, that might not get fixed for everybody. Secondly, if you've got that centralized team, that's the clear bottleneck problem. If they can't scale as more and more app teams need containers, that could be an issue. The base image team, it's able to build a strong domain expertise in the center, so that this team that creates the base images becomes experts in the base images the company uses. The cons there are that developers, the governance of making sure developers are using their images and not modifying them in ways they shouldn't, that can be a little onerous to some developers. They can feel like this is too opinionated. So you need to make sure that you have enough flexibility and communication channels are very open so that if developers can't use the image as it is for whatever reason, it's not their application that it's the problem, that they have that ability to get these things fixed quickly. Finally, with the separate base and security teams, the more hierarchical system, it's just an extension again of the second one. Communication becomes even harder now because you've got more and more teams. So you need to make sure that you have those signals, that you have that back and forth, so that the Java devs can talk to the Tomcat team and make sure that their app server is working for them and they're not go off and doing their own things. So let's look at how this looks from a kind of a more, how would you do this kind of point of view? And the first thing, the low-level team starts with the base image. They pull something in. In this case, we're pulling Python from Docker Hub, and we're using the 3.6.0 Slim version. We're adding the things that our company needs as a whole to this image, and we build it. Then you want to scan it. Even though this image even if you don't do anything to it, you still want to scan an image and source it on your own registries because you don't want to trust external sources to build your company's apps, right? So you would do the same thing with images. So you want to scan it and set a baseline. So in this case, we're seeing that this scan found 178 issues. Now, if all of those are coming from the base image and none of them have fixes right now, you may say, fine, that's our baseline. That's what we're going to start with. Every day, you should be, or every so often, I won't say every day, multiple times a day, but you should be rebuilding and checking to make sure that vulnerability count doesn't go up. If it does, that's an indication of there's probably a new version that will fix whatever new vulnerabilities have been found, or there's been something that has been, because something's been discovered that's vulnerable in your image, and you need to be aware of it. And you need to be able to alert the teams to say, hey, we don't have a fix for this yet, but the vulnerability database is telling us that this is the potential. So if we have other mitigating controls around it, we want to make sure we have them, right? So you want to set that baseline. And if the vulnerability counts go down, you reset the baseline down. It's ratchet it down, right? So the middleware image, that team comes in, they take this, they add their whatever they add for their Goonicorn thing here, and they see, oh, we've added 2 new vulnerabilities to what the base image had, because when delivered it says this was the baseline. They know, let's look at what we added, because we've done this. It's not the base image team's problem, it's our problem. We need to work on it. Now we could talk together obviously and try to fix those things, but we need to address it before we hand this to the developers. Now you could ignore issues. So if new issues come up that just aren't applicable to your company or your products, you could say these aren't applicable. Or if we have other mitigating, concern things that make it so that that can't be exploited. But you want to have an audit trail around anything that you are ignoring. This is a screenshot of our tool at Sneak. It's this just meant to be an example. You don't want to be the guy or the person who says, "Oh, we're ignoring this because so and so down in the 3 cubes down told me it's not a problem." No, you want to be able to say, "This is why we're okay with this vulnerability, and we're not going to remedy it right now. When are we going to remedy it? Are we ever going to remedy it? That kind of information needs to be logged somewhere so that the security teams know that it wasn't just literally ignored." And then finally, the application images. The application team gets the image, they add their stuff to it, and they do a scan on it, and no new vulnerabilities have been found. They're good to go. They don't have to worry about the baseline vulns because that's not their problem. So, wrapping up, I hope this gives you an idea of how other companies are dealing with this, with that supply chain. You'll hear the secure supply chain, which is a bigger topic than this, but that feeds into that topic of making sure you know where your images come from and who's been touching them and what's being done in them. Base image is probably the most important thing to worry about right now, especially as you get started. You need to know how all of your teams are using base images, where they're coming from, and how they're if they're trying to do any resolutions of their own. You want to know, define who actually fixes your vulnerabilities. Do all teams bear the burden of fixing the same issues? So do you have the first example where everybody's building their own images and having to communicate, hey, Debian XYZ has this vulnerability in a new version and has fixed it, and make sure they know about it? Or do you have a process to allow them to all know? Or do you have the base image team that handles it for them? Which gets into deciding how do you shift the responsibilities between teams. So if you have the siloed assistant set up, you might find that's not working for you. How can we move that into a base image that everyone, so come up with that strategy. If you're not doing the base images already, honestly, the base image team or the extension of that, the hierarchical team, usually is what most companies end up going to that I've seen. And then automation. Automate. This is, developers, automate. All of this stuff can be automated, no matter what tooling you use, whether it's ours or somebody else's, doesn't really matter. You want to make sure that everything you're doing is has automation, that you have audit trails, and that everybody is able to get the information at the same time, rather than email threads or Slack messages or something. So that's all the time we have today. Thank you so much for listening. I did include a link here to a demonstration application, kind of a repository that one of my colleagues has set up that kind of walks you through how you would do this multi-stage, that's a bad term, this multi-team build kind of an aspect. So go take a look at that if you're interested. There's my info if you'd like to get a hold of me, and thank you again for listening.
All right, thank you, Eric. There was a ton of great material in there. We're going to start live Q&A. So if you have any questions that you would like to ask Eric, feel free to drop them into the Talk Q&A the Talk Q&A channel in Discord. So Eric, I have a couple of questions just to get the discussion started. One of them is, what do you think of a concept of deadlines? So let's say that we do find a security vulnerability in an image that's patched upstream, and if you don't deploy a patched version of that image to prod within 30 days, some centralized team will just kick your CI pipeline automatically and send it on its way. Do you have any thoughts on that?
That's a great question. It's one I didn't actually think of for the slides, so now I get to update my deck. I've seen that before. It usually comes from legacy teams who have done the idea where if you didn't patch your servers, we're going to do it for you, or we're going to firewall you off, or something like that. In a container world, honestly, I don't see that that would be a problem usually if you're just going to kick off a pipeline that's going to automatically pull the base. Going back to what I was saying in my talk, though, the way to head that off, I think, is the proactive way to think about that would be the teams that are at the lower level should be automatically updating those base images. And I've seen, for instance, like in a CI and in a lot of integrated CI environment, a webhook would then get called when a base image is updated that triggers the Tomcat team, if it's a Tomcat shop, to update their image, which would trigger that push would trigger the image of any base images or any application images that are based on that to get an update and trigger a rebuild, or at least trigger a pull request creation maybe that creates a new Docker file with the change, or opens a Jira or whatever ticketing system you use that says, hey, new base image exists, and we see that you're using this. There's a bunch of ways to do it. It really depends on the tooling that your company already has on how to do it. But to answer your question, proactive is always better than reactive. So making sure that those base image teams are up to date and keeping up to date is key.
Right. And I think that kind of harkens back to your whole idea of automate, automate, automate.
Yep.
What we do might just be a reflection of where the organization is in its journey towards full automation. Some organizations, they're going to be able to actually, it sounds like you're suggesting, we do a waterfall down from the base image where everything could rebuild. And that's kind of an ideal world. But for an organization that doesn't feel quite comfortable with that yet, we would just send them notifications instead and have that trigger manual action. Is that right?
Yeah, in fact, one of the things that some of the scanning tools out there will proactively open pull requests when they see new vulnerabilities or new base image solutions. So you'll wake up in the morning and you walk in, and all of a sudden you've got a pull request on your repository saying, "There's a new Alpine image. You should probably update because this is the things it fits." Right there in your to-do list for the day.
Got it. Do you have any thoughts on organizations that are looking to transition out of that centralized team building all of the containers, or even just providing, say, base sets of infrastructure to something that's more distributed, something that's more dev friendly? Because that's probably a stage that a lot of organizations making a DevOps transition are in.
Yeah, gosh, we could do a whole talk on this, but the main thing from my point of view, and you have to know where I'm coming from, is we're a devs centric tool, or our company sells devs tools, is giving the developers tools where they can actually be players in that, right? So in the DevOps world, we all had development, ops, testing, all that shifted as far left as we can by having tools that allow the developers to actually have security be pulled left as well. And say, I wake up in the morning as I do my my pull and my first build of the day, all of a sudden my tool tells me there's new vulnerabilities. I then can raise the flag and say, hey, lead architect, security expert, I'm seeing this, and hopefully they've seen it too. But having the developers be proactively involved allows that DevSecOps to really start to gel.
All right. Yeah, that's great. If you have any other questions that you would like to ask Eric, we're going to be opening up a breakout with him in the talk breakout in Discord.